Hey guys, your boy Chili here. Welcome back to C++ Infrastructure. Got pretty good reception on the first video, so we're going to keep making some more of these videos, and we're going to keep on with the topic of IoC containers. Today, I want to talk about how we can parameterize our resolving of components out of our containers. So, I mean, we can resolve components out, but we can't really give them any parameters to construct them with. And that limits what we're able to do quite a bit. So we'd like to be able to resolve them out and pass parameters in while we're resolving. But before I jump into that topic, I got some ideas, some interesting ideas on how to solve that. That'll show you some cool techniques. But before we jump into that, there was a comment in here. Someone asked, what if we wanted to change component B? And that's a good question. I didn't really address it in this video because I wanted to keep it short in the first video. But the problem with component C is, sure, we can inherit from it, but ideally, we'd want to inherit and we'd want to override the function, but we'd probably want a function that did something similar, like that took components D processing and added something to it. But if we inherit from component C, we can no longer access component D because it's private. So that's the one little trick when you're designing components that are designed to be extended by other people in the future. Private can cause you problems, and there's a bunch of ways you could solve it. You could give, partial access. You could make a protected getter that gets, I don't know, like a component D reference. Get comp D or something like that. I don't know. And so this will allow someone who inherits to be able to access component D without changing the shared pointer. And that's if you want to lock things down more. And there's reasons why you would want to do that. But the easiest way, and the way that we're going to do here to keep things simple, and I mean, I do this in practice as well, and some people will say it's a terrible practice, but it's better than making everything public. So I just like to put my data members here, make them protected. So people inheriting, they'll be able to access them, and it puts more responsibility on the people who extend your classes to be able to understand them and to not break, any of the class invariants. But this is going to be the simplest solution, and it is often good enough, and it also can make your life easier. So make this protected, and then if we ever wanted to, extend component C, it now becomes very simpler. We can now access comp D, do processing plus better C. And then we could inject our enhanced component C into the container, and it should all run as expected. Except we don't have a matching constructor because, we should do using component C. We should just grab the existing constructor that component C already has. And so now we got more, better C, B, but better, and then A. So there you go. So making your private data protected is the quickest fix for, allowing people to extend your classes. Now let's get on to the real topic of the day. How do we allow people to pass in parameters when they're resolving a component, and we can use those parameters to construct the component? Now, my idea, my little cheeky idea here is that, so the base class for any component that we resolve, it will statically declare parameters that can be passed in when you resolve it. And our container will pick up that information using a little bit of metaprogramming, and we'll use that to construct the objects. So how are we going to give this a shot? So my idea is this, you have a component. What you can do, and this will be optional, we'll figure that out as we go along. So if I can figure out how to spell struct, so you could do, I don't know, IoC params. So let's put in a parameter here. We'll just do a std string str. So we're going to parameterize this component, string str, and when you construct it, it will now take in IoC params, and it will use them to construct the object. So we'll do, let's see here, std move params.str. There you go. And str will be used, I don't know, we could just, well, let's change do processing. We'll include format up here, and let's make it fancy. So it's going to format the contribution of B hyphen and then A's contribution in inserting this string parameter in here. So we'll do comp B pointer to do processing and then str. There you go. Okay, so this is our new little system here. How do we get the IoC container to route the parameters into here when we resolve a component A? So now we're going to have two versions of the resolve function and two versions of the register factory. One version of the resolve is going to take nothing, and the other version is going to take a parameters object. So we'll do this. All right, so the parameters object is dependent on type T. It's a subtype of type T. So for dependent types, you type type name, tell the compiler that we want a type name that is dependent on a template parameter type. IoC params. We'll just start off by taking them by value, and we'll think about that later maybe. So it takes in params. All right, so it has to call the generator with the params is basically how this is gonna roll through, except there's a little problem, and that is we defined generator to be a function that takes no parameters. So what we actually need is a new using for parameterized generator that takes in something like this. Now for the resolve with params, it should cast to a parameterized generator, and we'll just do a std move here. I may or may not look into std forward bullshits later on. So this tells us, okay, so now if we're casting to parameterized generator, that means that when we register the factory, we should register a parameterized generator. And so we'll copy pasta this bad boy. We'll say he takes in a parameterized generator. And this part is the same. So far, so good. Now we got to go to our framework. And component A, this generator is now not right. We need a generator that takes in component A, IoC params. There we go. And return, yeah, and then we do a std move params. So we'll take those params in and we will pass them on. Nope, not here. That's a mistake. As the second parameter to make shared. There. That should work. Let's build it. It did work. Beautiful. And now we run it and we get, bad anycast. All right. So here's the glory of the exceptions that come out of the standard library. They are very minimal. I don't like it. I don't like the minimal amount of information that they put into their message. So there's a bad anycast happened in here. So what we're going to do is to make our library a little better so that we can debug it in the future. We are going to wrap these casts with a try catch that will add more information So you see here, we're going to try to do an anycast, but if we get a problem that is a bad anycast, well, then we're going to say, okay, so we were trying to cast to this, the thing that we were trying to cast to, but the any actually held this type name. That's going to give us more information. And let's do that for this version here as well. And now when we run our program, yeah, we're going to see, okay, we could not resolve a service. We tried to cast from this type, which was the thing that was actually in the any, which was a parameterized. Yeah, that makes sense. This is a parameterized generator. That's the thing that was in the any. And we tried to cast to, a non-parameterized one. Okay, that seems like a problem. We know that A is parameterized, but our code in main isn't passing in the parameters. And that's what's causing the issue. Now, that's fine. We've got good diagnostics. We can catch this at the runtime when we run our program, as long as we try to resolve this. We hit a code path that resolves it. If we don't hit that code path, we'll never realize that error until maybe, we release to the public and then the poopy starts to hit the fan, as you like to say. So, is there a way that we could get the compiler to figure this out for us and tell us at compile time? The answer is yes, and it is a little cool thing that we can explore in this video. Basically, the idea is, so if a component is parameterized, it has this struct here, a struct with a specific name as a subtype. So if we detect that a type has this subtype, then we should make the compiler enforce that the generator should be parameterized, the generator used to register, and when we resolve, we have to resolve with the parameters. So how can we get the compiler to detect that and to make sure that we use the correct override? Well, since we live in, 2022, or whenever you're watching this video, which should be after 22. If it's before 2022, that's a really cool trick. We can create a concept. So we say that concept, a component is parameterized if it meets a certain requirement. So what is that requirement? Well, the requirement is that this statement should be able to compile. So a dependent type name, IoC params, we should be able to construct that type. And if this is valid, meaning if for a type T there is a subtype IoC params that is constructible, then that type T is parameterized. This is a parameterized component. And let's also create, while we're at it, another concept not parameterized, which is just the inverse or the converse, I forget, of parameterized. So if it is not parameterized, then it is not parameterized. Simple enough, right? So now we have these two concepts. And so now we can constrain our functions to only work with those concepts. So now the version of register that takes just a normal generator with no parameters needs a type T that is not parameterized. And likewise, the version that takes a parameterized generator requires a parameterized T. And down here, it's the same idea. We need a parameterized T here if we're going to pass in params. And this one should take in a not parameterized T. Now, if we do this, the compiler should complain. It should scream bloody murder. What the hell are you trying to do? And indeed it has. So here, it's saying, we can't find a matching overloaded function. could be this one, could be this one, but the parameterized one expects an argument and we didn't provide any, whereas the not parameterized one, well, we didn't satisfy the constraints. Now, this is a problem with Visual Studio. Ideally, it would tell you which constraints were not satisfied and why. It doesn't do that right now, but it will in the future. They're working on it. I have it on good word that it is coming. And this is why I actually refrained from using concepts up until this point, was because Visual Studio, it didn't give any good diagnostics, and it actually made it harder to debug your program when you used concepts, when really it should make it easier. But this is going to be fixed. So we can ignore it for now, the crappy diagnostics. But it does do the job that I wanted, which was it now finds our problem at compile time instead of compiling happily and creating a program that doesn't work. So now, we just need to give component A, and let's do the component A, IoC params dot str. We'll use the named initializers. I love these named initializers, and we'll get back to this because this is actually really useful. And we'll initialize it with a nice little parameter here. And now when we resolve out our component A, it should be initialized with this parameter. And there you have it. More, better C, B but better, A, hashtag electric boogaloo. So we have successfully parameterized the resolution of our components here. And I've added some stuff in here that's not necessary. You can get rid of this and it will be detected. So it will deduce the type that you're trying to initialize here. So this should compile, and you don't even need this .str. You can just use the positional to determine the parameter. So that works just fine. But I do like using the dot notation when you have multiple parameters. And I'll show you some really cool stuff that you can do with that in the future. But in order to use the dot notation for the compiler right now, IntelliSense isn't smart enough to give you that unless you actually type in here, component A, IoC params. Once you do that, then you get the IntelliSense information. Then you can see all the members, and it's very nice. All right, so we have the ability to parameterize, and we have the compiler checking our concepts, making sure that we use the correct versions for the correct components. Where can we go from here? Well, let's expand our example here just a little bit for component A. It's now going to have 2 parameters. Spice things up, and we'll just we'll give them different names. You have a meme and you have a dream. You don't let your memes be dreams, but we do want to take those in here. Those will become members, protected member data of component A. So we would like to move them in the constructor here. And then we'll change this up a little bit. Std format succinctly composing our string here for us. All right, so we've got meme, we've got dream. In this code here now, we have nice static data. Type checking, we can see here that this parameter does no longer apply. We need to change our strategy. So we have our meme, we can add our dream. See, when I type my dot, I get my list of parameters here. I can select, and we're ready to go build this. Hopefully nothing weird happens. Yep, there we go. We got both of our parameters there showing up in the output. Now here's the thing. A container might have, or not a container, a component might have a lot of parameters. And most of them will just be sane defaults that you won't touch, but only sometimes you want to change 1 or 2 of them. So it would be very annoying, like let's say there are 20 parameters to parameterize the creation of some complex component. It would be annoying every time if I have to create those, I have to put in those 20 parameters. Let me show you a little cool trick that we can do here. So let's define our IoC params. Let's make them optional. So std optional meme and std optional std string dream. Now what we're gonna do in our constructor here, we have our params meme value or, so if it has a value, use that. If it doesn't, and we do the same for the other one, value or. Here we go. Okay, so now what we've done is we've made our parameters optional. We've given them defaults. So let's now go into container. We're going to make one important change here. So the resolve with a parameter, we're now going to give that a default as a default constructed parameter object. And now we are able, if we just want the default, we don't want to customize it in any way, we can just call this without any parameters at all. It'll get a default constructed parameter object that'll have empty optionals that will be detected in here, and the defaults will be submitted or substituted. And now the reason why this works, because normally if you just called resolve without any parameters, it would be ambiguous whether you wanted this one or this one. But because we have our concepts backing us up, the compiler is able to figure that out without any ambiguity. And so this should work, and it should give us the defaults. And now if we wanted to do this, and override any one of the defaults that we want, it's very simple. We just call the one that we want to override by name and give it its new value, and that works out fine. So you see here, this parameter object is actually more powerful than just a normal parameter list for a function that you get in C++. You get your IntelliSense here. You want to get a list of what parameters are available. You got that right at your fingertips. And you can override any ones that you want in any order. In C++ functions, we can make a function that has defaults. Here's a function f, 3 parameters, and they're all default. So if I wanted to call f with no parameters, that's easy. That works. If I want to only supply parameter x, I can do that. But what if I only want to supply parameter z, leave x and y defaulted? I can't do that. I can't go, comma, 420. That doesn't work. That's not in C or C++. But with our parameter object, we can specify only the parameters that we want, leave the rest of them default, no problem. And you can do this in a couple of ways. Like I showed you, you can do std optional in here and then define the defaults in here. But like for std string, you could also just do it like this. You could put the default in here. Don't you guys? And then do it like this. This also works. The only downside with this is that this has to be, you have to be able to construct this without any other information. Whereas if you do it like this, you could run other functions and do it constructed based on other parameters if need be. You could use a lot more sophisticated logic to construct your defaults with an optional. You can detect whether something passed in was set by the user or whether it was intended to be a default. So using optional gives you more options, but you can also just do it like this and it will work if that is sufficient for your purposes. But no, I really like this idea of passing in parameters as an object and using this named initializer here to construct the parameter object and pass that into a function instead of just a list of parameters. I might even use it outside of the context of, containers like this. I mean, Python already kind of has this, right? They have those named parameters. So I don't know. I like this. I think it's a very cool little pattern. And here's an idea of how you can parameterize the resolution of your components out of an IoC container. And I hope you like it. Again, let me know. Let me know your ideas in the comments. I only touched on some basic ideas in this topic. You could obviously go a lot deeper, and I haven't because, time is of the essence. But I hope you enjoyed this. Hope you got something, besides the main topic here. We also got a little practice using concepts in here. Very cool. A little bit of template metaprogramming stuff. Just a little light metaprogramming for you. And, I want to do at least one, maybe two more videos on this topic of IoC stuff, and then maybe we'll do some other infrastructure stuff. I got ideas. I got big ideas for how to make a really nice logging framework, and I might put some videos up on that. Logging, pretty important when you're writing any kind of software, but definitely for a game engine. So yeah, hope you enjoyed the video. If you did, please click the like button. It helps a lot. And I will see you again with some C++ infrastructure.